Descriptive statistics, page 15 and 16. Number 3. Two baseball coaches compare the number of runs scored by their teams in the last 10 games. The Rockets and the Bulls. Show that each team has the same mean and range of runs scored. They're trying to make IB international by talking about baseball. But in baseball, they don't say matches, they say games. So how do we figure this out? We need to put this data into the calculator. We do that with stat edit. I'm going to put this data into list 1 and list 2, and I'm not going to bore you with me typing those in, but show you how to clear it out with the clear button. And then I'm just going to start putting in here 0, 10, etc., and then I'm going to put the bullets here. So I'm going to pause while I do that. Okay, so I put the Rockets in list 1, and I put the bullets in list 2, and then I'm going to do one by one. I'm going to find out what the mean and the range are by doing one var stance. And what do I put in frequency list? Nothing, because I'm not using frequency list. Okay, and so the mean is 5.7. Okay, and the range we find by taking the maximum minus the minimum, so 11 minus 0. So the range is going to be 11. And then the last thing is the standard deviation, which is 3.9. Okay, and then, is there anything else they asked for? Okay, and then we're going to find the same thing out for list 2. One var stats, and this time we're going to do list 2. Then we're going to calculate. Okay, same mean. The range is going to be 12 minus 4.5, no, 12 minus 1, which is 11. It's also 11. And then the standard deviation is 3.29. Okay. So we showed that each team has the same mean and range. What team's performance do you suspect is more variable over the period? So since mean is the same and range is the same, then we look at standard deviation to see which one varies more, and we see that the Rockets have a higher standard deviation. So I'm going to say Rockets. Okay, and so we confirm that with the standard deviation. Now, could we figure that out without the standard deviation? I guess we could kind of look at the extreme values, see how many extreme values there are. So for the Rockets, let's see. That's pretty extreme. That's pretty extreme. So there's a lot of extreme values. 8's kind of extreme. Okay, what about the bullets? How many extreme values are there? No, this one, this one. So you can see the Rockets have more extreme values. So even without looking at the standard deviation, you might say the Rockets are more variable. Then finding the standard deviation, we confirm that it is the Rockets, right? Now we find out that the Rockets have 3.9 versus 3.29. Does the range of the standard deviation give a better indication of variability? Standard deviation, because it looks at all data points, right? Because the range only looks at the minimum and maximum. That's it, right? Okay. 7. The following table shows the decrease in cholesterol levels in 6 volunteers after a 2-week trial with special diet and exercise. Okay, find the standard deviation of the data, recalculate the standard deviation with the outlier removed, and discuss the effects of an extreme value on the standard deviation. Okay, so first what we're going to do is we're going to put in this data into here. And I won't bore you with that, so I'll pause for a second. Okay, there we go. I put in L3. Then we're going to go to stat calc 1 bar stats. L3. Okay, and then the mean is 1.02. The standard deviation is 0.809. Okay, and then it says recalculate the standard deviation with the outlier removed. There's the outlier. It's like much higher than the other values, right? So let's try figuring the standard deviation again without this point. So I delete that one, and then I try again. 1 bar stats. Now the standard deviation is 0.14 or 0.150. Okay. Discuss the effect of an extreme value on the standard deviation. Outlier causes standard deviation to become much larger. Okay. Page 535 reading. Sometimes populations are very large, so a distribution is measured statistically by choosing a random sample from the population, assuming that the population is similar to the sample. In the table at the right, write the notations we use to distinguish statistical measures of a sample and a whole population. In order to assume the population can be characterized by the sample statistics, the sample must be sufficiently large and be taken in a way so that the results are unbiased. Okay, now we're going to write down the notation we use for mean. With the sample, we use X bar, and for the population, we use the Greek letter mu. And then for variance for sample, we use S sub n squared. For population, we use sigma squared. For standard deviation of a sample, we use S sub n, the square root of variance. And for standard deviation for population, we use sigma. Okay, so we use Greek letters for population, and we use regular Roman letters for sample. Okay. But as you saw in the past few exercises, we often use sigma instead of S to denote standard deviation, even though they're saying that we should use S sub n for the sample. Okay. A random sample of 87 deer from a huge herd had a mean weight of 93.8 kilograms with a variance of 45.9 kilograms squared. So they're talking about here S sub n squared, and here they're talking about X bar, because it says a sample of 87 deer. Okay? Find the standard deviation of the sample, hence estimate the standard deviation of the whole herd. Okay, well we know that the variance of the sample is S sub n squared equals 45.9. In order to find the standard deviation of the sample, we just need to take the square root of 45.9. 6.77. Okay. So 6.77 kilograms. Okay, notice that the units also are square rooted. Hence, estimate the standard deviation of the whole herd. Well, you can use S sub n to estimate sigma. So we'll say that the whole herd is also going to be 6.77 kilograms. Okay, if we were more advanced in statistics, we might adjust that number to be slightly larger. But right now, that's fine. Find an unbiased estimate of the mean of the whole herd. So what we can do is we can take the X bar value, which is 93.8, and we can take that and use that for the mean of the whole herd too, 93.8 kilograms. The weights in grams of a random sample of sparrows are as follows. I put those numbers into list 3 here, and then I'm just going to do stat calc 1-bar stats for list 3. So the mean here is x bar, which is 77.5. And the standard deviation is the sigma, which is 7.44. So one thing that you need to be careful of is, although they say that for a sample, the S sub x is the standard deviation, you should always just look at the sigma x. You should ignore the S sub x on the calculator, okay? Estimate the mean and the standard deviation of the population from which the sample was taken, and now you're simply going to say mu equals what you got for x bar, and S sub x, I'm sorry, this should be S sub x, S sub n, and this is going to be sigma. Okay. As before with group data, standard deviation for group data, we use the midpoint of the interval to represent all the data in their interval. So I think what I meant to say here is, as before with grouped frequency, group data frequency histograms, we continue to use the midpoint. So, below is a sample of family size taken at random from people in the city. Find the sample mean and standard deviation, then estimate the mean and standard deviation of the population from which the sample was taken. So, here we're just going to, once again, put this data into the calculator. We're going to put it in L1 and L2. We're going to put in L1, and the frequency we're going to put in L2. Okay, I've typed it in, and now I'm going to do stat calc 1-bar stats for the two lists. I'm going to put first L1 in for the data, and then for L2, for the frequency list, I'm going to put L2, and then I'm going to run it, and then I'm going to take out the numbers for x bar, which is 1.72. And then for the sample standard deviation, I'm going to get the sigma value here, not the S value, the sigma value, 1.67. And then I can estimate the mean and the standard deviation for the population with these same numbers. Okay? All right. Number 3. The number of toothpicks in a random sample of 48 boxes was counted and the results tabulated. Find the mean and standard deviation of the number of toothpicks in the boxes. Estimate the mean and standard deviation of the population from which the sample was taken. So, once again, there's a lot of toothpick boxes, millions and millions. We chose 48 and found this distribution of number of toothpicks, and we are going to use the calculator to figure out what the mean and the standard deviation of these are. I've typed my number of toothpicks into L1 and my frequency into L2, and I'm going to do a stat calc 1-bar stats, L1 and L2 for list and frequency list, and then I'll calculate. I'm going to get my x bar out of here, which is 37.3. That's my x bar. And my S of n is going to be the sigma value, which is 1.45. And then to estimate the mean and the standard deviation, which is mu and sigma, I simply use those values. Okay, 1.45. Okay, moving on to number 5. Last one. The weekly wages in dollars of 200 randomly selected steelworkers are given alongside. Estimate the mean and the standard deviation of the wages. Estimate the mean and standard deviation of the population from which the sample was taken. So the only thing different about this one than before is, since we can only type in one data number into the calculator for each one of these intervals, do we use the left value? Do we use the right value? No, we use the midpoint value. So let's write down the midpoint values for each one of these, just so you can see what we're supposed to use. So this would be 365, right? This would be 375, 385, 395, 405, 415, 425, and 435. So in the calculator, we're going to put this list here, and then we're going to put this list for the frequency, and then we're going to follow the instructions about finding the mean and the standard deviation. So stat, edit, and we're into L1 and L2. I'm going to put this data, and I won't bore you with the data entry. I'm going to do this offline. So you can see here in list 1, I put in all the midpoints here, and then I followed them up with the frequencies. And then I'm going to do a stat, calc, 1 var stats, list 1 and list 2, and then calculate. And I'm going to grab the x bar value and the sigma x value. So for A, I got x bar is equal to 390.3, and I got S of n equals 15.9. And then B asks me to estimate mu and sigma from those values. I just simply put the same values. Okay. All right. That's it.